Herzlich willkommen, volles Haus. Thank you for joining this morning. I have to say, quite a few interesting presentations already this morning, of which a lot of elements will come back in the coming 20 minutes, because what I would like to discuss with you this morning, is what we see as an outlook on refrigerants, but then particularly for the European markets. Allow me to first take a step back. Why decarbonizing the used building stock is indeed that important? Well, as you can see on the left side, and I think it was also mentioned by the colleagues of WICA, the greenhouse gas emissions today, about 40% of those are currently related to some link with the building sector. And if you look to the right side of the slides, you can see in basis of energy consumption as such, that if you look to an average household on the left and an average office application on the right, it ranges between 80 and 40% of the energy consumption that is linked somehow to an HVAC or R equipment. So there already the link between the decarbonization and what we are celebrating here on Chilventa, the HVAC and R sector. And if you look to a typical HVAC system, and in this case this would be a commercial air-to-air system, it's important for later on in the presentation as well that we identify once again the embodied carbon within for example, commercial air-to-air system, consisting of the carbon which is coming about through production, construction, transport, the potential refrigerant emissions, of course, maintenance, end-of-life waste disposal, processing, etc. And then on the light blue area is what we call the operational carbon, literally as it says, the energy you use to make your system run, and the energy, the way it has been produced to come into your system. So this is on the operational carbon side. And this is, of course, the importance there to bear in mind efficiency of the heat pumps, which has taken a lot of, I would say, interest in the last decades, and which have made heat pumps the efficient machines they are today. Now, this graph might exaggerate it a bit, but what we want to say here is that along the time, when we get more access to greener sources of energy, is that the portion of the embodied carbon will actually increase within your HVAC system. And there immediately you already see the link with the choice of refrigerant, which is indeed part, as we saw earlier, of your embodied carbon footprint of a CO2 system. Another element which was touched upon earlier this morning, and I think also mentioned yesterday on the EPE symposium, two graphs of the EPE, and on the left you can see that the importance of heat pump and decarbonizing our buildings will only increase. As you can see there, literally, the delivered heating by any type of heat pump will grow sixfold by 2050. And then if you look on the right side, again, the more access we get to lower sources, lower carbon energy sources, and with the lower refrigerant emissions as such, is that the impact of heat pump emissions will at any time and always be much lower than the avoided fossil fuel emissions. So in other words, turning it around, bringing bigger hurdles on introducing heat pumps might actually have the exact opposite effects and keep the fossil fuel emissions and CO2 emissions related to that actually growing. So we need to be very, very mindful of that. Of course, we touched upon it earlier this morning in other presentations. The F-gas regulation has now been reviewed in 2024. The stricter phase-down paths are known, and it's all up to us to indeed make sure that we use lower GWP refrigerants, that we reduce the charges in the first place, not to forget, and that we, of course, make all possible efforts to keep reusing refrigerants as much as we can. We need all stakeholders to participate in that exercise to have this carousel running around and have recycled refrigerants kept in use. Again, slowing down the heat pump rollout due to unavailability of quota, or indeed to other restrictions on the use of alternative refrigerants, we have to be really careful with that, not to slow down that rollout of heat pumps and actually have the opposite effect and having higher carbon emissions through fossil fuel use. Now, we can say that in the fact that there is a timed introduction of the product bans and of course also the stricter phase-down path along the years, we can say that to some extent technical hurdles have been considered. You can see that if you take, for example, the ones on the left, what we display here for your convenience is the example of the product bans GWP 150. And what is very obvious is that if you look, for example, on the left side, and you look to air conditioners, heat pumps, depending if you are looking to air or air-to-water, the timings of these product bans have been considered, taking into account whether it's technically feasible, if so, and at which timing to actually make that step towards lower GWP alternatives, or even so indeed natural refrigerants, of course. However, next to these technical hurdles that have been to some extent considered, we can also say, have they actually been sufficiently considered? Customer preference, are these always looked into? Are we looking also to practical installation hurdles and application hurdles? We believe still there's some work needs to be done. I will come back of this, of course, in the later slides, but the fact that there are timings already fixed for reviews, the fact that there is a phased introduction of these product bans, and the fact that there are already safety exemptions foreseen exactly describe the reason that we cannot say today that you can just simply shift to lower GWP alternatives without looking to all elements that you need and making the right choice of the right refrigerant for the right application. And this is what we would like to display on this slide. There is no one-size-fits-all refrigerants, and some of these were also mentioned in the slides by Mrs. Voigt. For example, starting on the right, the affordability. Are we really taking affordability sufficiently into account? Looking to ease of installation, looking to the cost of the equipment as such. Also looking to the left side, obviously, the environmental impacts. Needless to say there, the global warming potential is talk of the town. But what about safety? It is still a fact today. There are many applications today in the European market where safety is a major concern. And then I don't only talk about installing the units, using the units, but also make sure you can transport and store them in a safe way, that you commission them in a safe way, and that you can also decommission them in a safe way. All these elements have to be taken into account. The same with future readiness. I think system operation cost speaks for itself, but also the fact whether or not refrigerant can be recycled and reused should be sufficiently looked into. And I want to come back again to this element of affordability. What good does the entire industry do if we indeed find a refrigerant which has low GWP, is energy efficient, has a good toxicity or low toxicity, in other words, is not flammable, but what good does it do if we have to make the unit so bulky, so heavy to transport and to produce, to reach the same energy efficiencies that are being imposed on the industry? Hence, also there, the affordability needs to be also looked into that perspective, taking into account the size of the units, avoiding bigger material costs, and as such, remember the first slide, a bigger embodied carbon at the end of the day. So, if we look to these four elements in a choice of refrigerants, and of course we are at Chilventa, so let's start with refrigeration. If we look to the right choice of refrigerants, I will not dwell too long on those, but as you can see here, because it's technically feasible, already the jump was made to different CO2 applications, R290 popping up in the freezers and monoblocks, and also R454C in the monoblocks through semi-industrial monoblocks as well. Again, if you want to find out more, don't hesitate to visit us in Hall 7. Because I would like to dwell a little bit longer on the next two slides. This is the picture we try to collate in terms of refrigerant choice. Here, in this case, for the air-to-water applications, hydronic solutions. Looking to the top of the slides, also there, I think, if you look to chillers, applied systems, on the commercial side, various refrigerant options are being considered, from small to large applications, again, taking into account safety, environmental impact, and affordability. But I would like to have a look together with you on the bottom of the slide, where indeed we see that the transition away from R410A to R32 and also to R290 is being taken, also on air-to-water self-contained heat pumps, or the monoblocks if you wish. But the statement I would like to repeat here today is that we see limitations in terms of refrigerant charge and application size. And we would like to appeal to all stakeholders to also consider alternatives, particularly on the split-type air-to-water heat pumps, which could, for example, be R454C, and I'm happy to see later on other presenters will also explain the benefits of that refrigerant, to make sure that those applications which today cannot be covered with propane also get a decent answer on their market requirements. I will dwell a little bit longer on the next slide, because indeed on the air-to-air side, we are now on the air-to-air applications. Also here, the move towards propane R290 split units is important. Many manufacturers are investigating this thoroughly. If you look around, many already display units, but I deliberately mention here small splits. And why is that? What we believe is not showing sufficient transparency, and is the fact that even with propane splits, with all the virtues they have, you cannot today cover all applications in all capacity classes, and there is more transparency needed in making that clear to the markets. We appeal to other stakeholders to also here consider alternatives where you can allow for bigger refrigerant charges in a safe way and with a lower GWP, and 454C could play that role. And then I see you thinking, of course, but hang on, you still have a GWP of 145.5, so it cannot be a longer term or a final solution either. That may be true, but as we know, as we speak, there are still investigations ongoing on alternative refrigerants having the same chemical and physical characteristics, allowing us maybe for this R454C to be the necessary stepstone to a later refrigerant coming into the markets in a few years' time. CO2 systems in terms of larger split units also should play their role, then particularly looking to retail applications and small commercial applications as well. All players, and then I don't mean only manufacturers, but also the part suppliers, have to pay sufficient attention in also starting the investigations to these two refrigerants to make sure we are there in time and that we have all applications properly answered to. Not in the least also for larger commercial applications for the whole VRF market. Yes, traditionally big users of HFCs, but also there, even though many manufacturers in the meantime have provided a fairly strong lineup of R32 units, also there the product ban comes into place end of December 2032. So already today we should investigate properly also CO2 solutions in that VRF market. And I can tell you that in April next year, Daikin will be launching a first range of CO2 VRF systems, so more information to follow on that in the months to come. Briefly going back to that matter of application constraints, I think it was also mentioned earlier and yesterday also on the symposium. I was talking about transparency, and there, even though indeed we see R290 splits coming up, which is fully supported also by Daikin, we have to, and there I repeat what I said before, we also have to be transparent in the fact that many applications which are absolute mainstream today are also today simply not allowed. We have to be transparent there to all stakeholders in the market, not in the least the end users as well. I think it's also the right time to talk about product standards. You can see two different color shades on the slide on the right. In fact, the harmonized product standards today only cover the areas in the light blue area. We believe that anyhow, as manufacturer having the full responsibility for a full product life cycle, other elements have to be taken into account as well. What about the safety of our installer partners? What about recyclability? What about, as I mentioned before, the storing and transporting of alternative refrigerant solutions. All of these we would really like to appeal on having a more unified European guideline on how to properly deal with all these elements which today are not captured in the harmonized product standards. A quick look again also on combining, in this case, a heat pump on R290 and R32. Again, I want to underline, the benefits are there. There is absolutely no complaints on efficiency. We can be happy of having lower refrigerant charges, but that's the factory charge. There are limitations on how charges could have to be, for example, in the case of bigger capacity units, multi-split units are today not answered to with the use of propane, and that we have to be mindful on the balance between size and cost when thinking about refrigerant alternatives. So with this, ladies and gentlemen, I would like to conclude today with this summary. Let's not forget that when we choose refrigerants, we have 4 elements to take into account. And this is, by the way, not only the case for manufacturers as such, this is also the case for our small to medium enterprises. Every choice, every decision we take in the next years is also in favor or disfavor of the core of the HVAC industry, which are our installing partners. And we should really make this quite clear also to the policymakers and to all stakeholders, part suppliers, manufacturers, to think indeed about alternatives. After R32, R290 will play its role, but there are downsides in terms of safety and affordability, even having positive benefits in terms of energy efficiency, and that we appeal to all stakeholders to also look to alternative refrigerants like for R5-4C, like CO2, particularly for R5-4C, on bigger split applications and light commercial applications, being an A2L, already having experience in the market with R32, and with CO2 being an A1, indeed being non-flammable, but indeed having a possible downside on affordability and unit size. So all these have to be properly balanced to come to a answer to all different applications that all of your customers and the end users have to provide today. And with this, I see that I'm nicely in time to thank you for your attendance and leave the word to the next speaker.